What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Security Plus certification exams. So let's get into it. In this video, we're diving into an incredibly critical topic in cybersecurity. We're going to be talking about resilience and recovery in security architecture. So picture this. You're managing an enterprise IT environment and suddenly an unexpected power outage, cyber attack, or system failure hits. What happens next? Well, your organization's ability to recover and remain operational depends on the architecture and process you've built around resilience and recovery. So let's unpack this together. By the end of this video, you'll understand high availability, site considerations, platform diversity, capacity planning, testing, backups, recovery, and power systems. And these concepts, they align with the CompTIA Security Plus 701 exam objectives. So listen closely because this could make a difference on your test and in your career. All right, so first up, let's talk about high availability. So high availability, this ensures that your systems remain operational with minimal downtime. And this is crucial for critical applications and services that your organization relies on. So the first aspect that we're going to talk about is load balancing versus clustering. So load balancing. So imagine a website receiving thousands of requests per second. Without load balancing, a single server might crash. A load balancer, this distributes traffic across multiple servers, ensuring no single server gets overwhelmed. And this enhances both availability and performance. And then we have what is called clustering. So in a cluster, multiple servers work together as a single system. If one server in the cluster fails, another takes over instantly. Unlike balancing, clustering, this focuses more on failover and redundancy rather than distributing the load. All right, now let's consider what is called site resilience. So organizations, they must plan for disasters by having secondary locations. And the first type of secondary location is called a hot site. So this is a fully operational duplicate of your primary site, and it's ready to take over in real time. But the downside to a hot site is it comes with very high costs. You have what is called a warm site. And this is a partially configured site that requires some setup to become operational, and it balances cost and readiness. Then we have what is called a cold site. This is an empty facility with basic infrastructure. It's the cheapest option, but requires the most time to get running. And then we have what is called geographic dispersion. So to mitigate the risks of natural disasters, you want to ensure your backup sites are geographically distant from your primary site. So for example, if your primary site is in California, a backup site in Nevada might not be far enough to avoid an earthquake's impact. All right, next let's talk about platform diversity. So this means using varied technologies and systems to avoid a single point of failure. So for instance, relying solely on one operating system or vendor can make your infrastructure vulnerable if that specific platform is attacked or compromised. So diversifying this essentially mitigates these risks. Then we have what is called multi-cloud systems. So another growing trend is multi-cloud systems, where organizations use services from multiple cloud providers. And essentially this avoids vendor lock-in and enhances resilience. So if one provider's servers go down, the others can ensure continuity. However, managing a multi-cloud environment, this requires robust planning and integration. All right, so let's talk about continuity of operations. So continuity of operations, this is about maintaining essential functions during a disruption. And this requires detailed planning, including identifying critical processes, establishing a chain of command, and ensuring communication channels remain functional. And then we have what is called capacity planning. And this involves assessing what you need to keep your systems running smoothly, even during unexpected spikes in demand or disruptions. So some of these aspects could be people. So do you have enough trained staff to handle emergencies, and are they cross-trained for versatility? Another aspect is technology. Can your current hardware and software scale during peak loads? And then we have infrastructure. So are your data centers, cooling centers, and power supplies equipped to handle worst case scenarios? Next, we have what is called testing, and this is crucial to ensure your resilience plans work when needed. We have what are called tabletop exercises, and these are where teams discuss and role play their response to hypothetical scenarios. We have what is called failover testing. This simulates failures to test whether systems correctly switch to backup resources. We have simulations. This tests plans in a controlled environment to mimic real-world scenarios. Then we have what is called parallel processing. So this runs backup backup systems alongside primary ones to test their readiness. And speaking of backups, they are the cornerstone of resilience. They ensure that data is not lost during a failure. So we have on-site versus off-site backups. On-site backups, they are quick to access, but off-site backups, they protect against local disasters. Then we have what is called backup frequency. So you want to back up data based on its criticality. Critical systems might need hourly backups, while less essential data can be backed up daily. Then we have encryption. So you always want to encrypt backups to prevent unauthorized access. And then we have snapshots, and these are point-in-time copies of data that allow for quick restoration. Next, let's talk about recovery real quick. So recovery strategies, they ensure your systems and data are restored efficiently. And two aspects are replication and journaling. So replication, this is a continuous copy of data to a backup location. Then journaling, this is a log of changes that are made to data, ensuring updates aren't lost during recovery. And then finally, let's talk about power resilience. And two aspects of power resilience are generators and UPS, are uninterruptible power supplies. So generators, they provide long-term backup power for critical systems during outages. And in UPS, this keeps systems running for a short time until generators activate or systems are safely shut down. All right, so we've covered a lot in this video. We talked about high availability, site considerations, platform diversity, multi-cloud systems, continuity of operations, capacity planning, testing, backups, recovery, and power systems. Each of these components, they play a vital role in ensuring your organization can withstand disruptions and recover swiftly. So remember, resilience isn't just about technology. It's about planning, people, and processes. So if you prepare thoroughly, your organization should be ready to handle whatever comes its way. Now, with all of that said, let's do some of this wonderful check on learning. So the first question is, which of the following best describes the purpose of load balancing and ensuring high availability? Is it to provide failover capabilities for disaster recovery? Is it to distribute network or application traffic across multiple servers? Is it to maintain backups in multiple geographic locations? Or is it to encrypt data during transmission? And the correct answer is it is to distribute network or application traffic across multiple servers. So load balancing, this improves high availability by distributing traffic across multiple servers, ensuring no single server is overwhelmed. And this minimizes downtime and improves resilience in case of a server failure. Next question, what is the primary advantage of a hot site over a cold site for business continuity? Is it a hot site requires minimal setup and can be operational almost immediately? Is it a hot site is less expensive to maintain than a cold site? Is it a hot site requires data replication only after a disaster occurs? Or is it a hot site has no geographic restrictions? And the correct answer is a hot site requires minimal setup and can be operational almost immediately. So hot sites are fully operational facilities with real-time data replication and ready-to-use infrastructure. They ensure minimal downtime during a disaster, making them suitable for critical operations. In contrast, cold sites, they require significant setup before they are able to be used. And our final question, during disaster recovery testing, which method involves simulating a real-life disaster scenario without disrupting actual operations? Would it be failover testing, simulation testing, parallel processing testing, or tabletop exercises? And the correct answer is this will be a tabletop exercise. So with tabletop exercise, this is a discussion-based testing method where stakeholders simulate their roles and responses to a hypothetical disaster scenario. It is non-disruptive and focuses on evaluating plans and procedures, unlike simulation or failover testing, which may involve active systems.